Alright, in this video we're going to talk about functions in Python, what they are, and why you want to use them. Basically, functions are a named block of code. So, they can be one or more lines of code, and you associate a name with them. That way, when you call the name, it will actually go up and jump around to wherever your function is written and perform the actions involved with that. Now, you may ask, why in the world would I want to do that? Well, two reasons, and a lot of times both these reasons will be your motivation, but one or the other will be good enough. One is this gives you the ability to modularize your code, and what I mean by modularize your code is oftentimes even with small problems, they're easier to work with if you break your main problem into smaller pieces, and you can use as you break it in your program into small or your problem into smaller pieces, and you take care of those. Oftentimes you'll want to put them in a function, and it makes it look nice and clean, and it makes it when you go through the routine and do each little sub problem to get your final answer, you can use functions and just call them sequentially. It makes your main code really short and concise and easy to deal with. The other one is for efficiency purposes. There'll be situations where you may have a program that repeats the same action over and over again multiple times in different areas of the code. Well, instead of typing that same exact code over and over again in different spots, you can just write a function that does whatever you need it to do, and then the 15 different places you may need to use it, you can just call the function instead of writing that 2 or 4 or 20 or 100 lines of code that you would have to write each time. Alright, let me show you a quick example of a function. This is going to be the general syntax for it and how it always look. It'll always start with the keyword def, which means define. You will give it you will name the function, you give it some arbitrary name. A lot of pretty much the same rules for variables apply. Just that apply for variables also apply for this. Which means, for example, a big one is you can't give the function, same thing with variables too. You can't give it the same name as a keyword. For example, def is a keyword. If, while, for, print. There's a bunch of them. You can actually Google them and see the whole list. Um, and also, you can't have a variable and a function that have the same name. That'll also cause issues because when you type out that name, the Python interpreter won't know if you're trying to call the function or if you're talking about the variable. But anyway, you want to kind of give it stylistically. It's a good idea to give it a name that kind of explains what it's going to do. In my case, for this first one, I'm just going to print out hello. So I'm going to call it say hello because that's what it does. Open parentheses, close parentheses. Right now we're leaving those empty, but there's actually a use for them, and I'll show them when I expand this function out a little bit more. And then you end with colon. And just like with the if statements and while loops and things like that, you go to the next line, you'll tab over one level of indentation, and then everything that you indent over, that's tabbed over, will be considered part of the function and will run that way when you call it. But in my case, it's just going to be a single line, which is print hello. Then once I'm done with that, I'm going to go ahead and go a line or two down, and we're going to call the function. You call the function just by saying its name, and then open parentheses, close parentheses in this case, and then in future, in the next case, there'll be stuff inside of here, and I'll show you what you do then. And when I run it, you will see that it prints out hello. So what's happening is I call this, or it's just when I call the function, where it's to say hello is at, then Python jumps back up to here, goes in, and runs all the code that's associated with it, and then it comes back to where it called the function from. So you can kind of, this is another case of, like I said in earlier videos, about how you can, for the most part, Python starts from the line 1 and just sequentially goes down, but there's ways to change that. Well, a function is another way to change, another example of that. When a function is spotted by Python, it doesn't actually run it. What it does is it sees this keyword def, and it's like, oh, this is a function. Okay, for my reference, there's this function called say hello. So I'll make sure I know that exists, and and if there's any parameters or arguments associated with it, I'll note that. In this case, there's not any; it's blank in there. And then I'll just kind of sweep through and make sure there's no errors with the code in here. But other than that, I'm not going to run the code unless it's called, like right there. And you call it just by saying the name of it, and then open parentheses, close parentheses. If there's any kind of arguments, which I'll show in this expanded example in just a second, then you would have the arguments in here also. Now, that being said, you may not notice the syntax looks a little bit familiar. We've been using functions in previous videos. It's just I didn't tell you they were functions because we hadn't got that far yet. perfect example is raw input. You noticed it was a name, raw underscore input, and then you had parentheses inside of that. You put in a string or a variable that contained a string that that would state whatever you wanted it to see to the user, and then it would return what the user entered. Well, that's completely a function. That's actually a function with arguments and a return statement, which I'm about to go over both of those. But as you saw, in this simple case, it said print hello, or just print out hello. Now we're going to make it a little more sophisticated. We're going to give it a single argument, and I'm just going to say person's name. And I'm going to say print hello, comma, person's name. And then inside of this function call, when I call it now, I'm going to say, let's put in Brandon. No, I'll purchase that. Anyway, you print hello out, or you're going to run this, and then you'll see instead of just printing hello, it'll say hello Brandon. What I did is I gave this function what's called an argument. What that means is now when Python looks at this, it says, okay, you're defining a function, you're going to name it, say hello, and when you call it later on, not only do I need to recognize this name, but I also need to make sure that you've passed one piece of data along with it. And just for programmers' convenience, you arbitrarily give it some name. That way, when you refer to it inside the function, Python knows that you're referring to the data you passed. Like a lot of times, people will get stuck in the habit thinking that whatever they name up here, whatever variable name they put up here to represent the data, it must be the same down here. That's simply not the case. As you can see, I just hard-coded a string in there. Yes, I could have said person's down here outside the function. I could have said person's name equals Brandon and then passed that variable, but it's not actually required to do that. So it's kind of an important thing to remember. But anyway, since I've set this function up and defined it this way where it expects a single argument, a single piece of data, if I try to call it where it doesn't match that exactly, in this case it has no arguments when I call it, it'll actually throw an error and say that that say hello takes one argument, but you gave it 0. So it has to actually match exactly. Well, that's like the basics of calling a function with and without parameters. The number of parameters is actually arbitrary. You can put in as many as you need. I mean, if you look at documentation for Python, some of the really more complex functions might have 7 or 8 different things in their variables that get passed to it. So you can have 0 or 1 or 2 or 3, so forth, so on. All right, next we're going to talk about return. I'm going to give a really kind of simple example here. I'm going to make a function called divide. Now, hence the name, it's going to do division. Obviously, we can do that without using a function. We did that in the first video, but just bear with me so I can show you the idea of the return statement. I'm going to have 2 variables passed that I'm just going to call num1 and num2. And all it's going to do is it's going to take the value, this num1 value, the num2 value, whatever they are, that's passed to the function, and it's just going to say num1 divided by num2. But in front of that, I'm going to put the keyword return. Now, when I call this function, I'm going to go ahead and say print here. I'm going to say divide, the call, you say the name of it, and then inside the parentheses you pass any arguments there are. I'm just going to once again hard code say 4 and 2. So num1 is going to be 4, num2 will be represented by 2 because they go in the same order. The order, the order of this matches the order of that for representation purposes. So 4 is num1, 2 is num2, and then it's going to do num1 divided by num2, and then there's this keyword return. What that means is it's going to take whatever results from this division, or if you had some data saved in a variable, whatever that you say the return, it's going to pass it back up to here. You can kind of think of it as taking that, because 4 divided by 2 would be 2, so you can think of it as calling from there, where I was just at, from here. Well, whatever. What did that do? Well, Control Y apparently doesn't work on that. But anyway, I had divide. I had 4 divided by 2. You can kind of think of it as taking, as this calling divide. It goes up here, and puts the 4 there, the 2 there, and then it comes down. Does the division because it recognizes those 2 as 4. That is for the data that's held inside of them. It does a division, and then it returns it back. And when it returns, you can think of it as taking where you called the function, deleting it, and replacing it with whatever you returned, which in this case would be a 2, because that's what 4 divided by 2 would be. And you'll see that when I say this thing and I call it, it's going to print hello. Oh, whoop, I didn't fix that error. Actually, let me just comment that out because we're not using it right now. That way it doesn't run. Okay, anyway, we'll run it and you'll see it shows 2. Now, like I said, it is exactly kind of what you expected. It's actually raw input. If you remember that, how you would pass it a string or a variable that contained a string, and that's what the user would see. Then it went around until they entered something, and when they entered it, I kept saying that you could think of it as deleting where raw input was called and replacing it with whatever the user entered. Well, that's because raw input's a function and it actually uses the return statement, and that's what's happening. I just didn't want to say that because we hadn't talked about functions yet. And once again, with this stuff, you want to play around with it. I'm kind of giving you the quick bird's eye view on what's going on. The last thing I want to show you that's kind of neat, and I'm going to do it with an actual library that's already pre-written, and then I'm going to do it with this code also. I'm going to just delete this and just leave the function definitions here, and go ahead and save it. And I'm going to go to this other file that I've called test import. I'm going to use the keyword import, and what import does is it takes either libraries or data from another file, and it basically, you can think of it as wherever you call the input, it takes the data from other files that you've called, copies and pastes those files contents right here. I'm actually going to use a pre-written library that's standard that comes with Python among many libraries that comes with Python when you install it, called math. So we're going to just say import math, and then we have access to all this stuff, all these functions and different things in this math library without actually having to write it ourselves. So for example, just a quick example, you have math.pow, which is power, raising them to a power. So we'll say raise, the first argument would be your base. So we'll say raise 2 to the 3. Okay? And then the next one we'll say math.pi. And math.pi, with pi, it's pi, the 3.14, yada yada yada. Well, that's actually just a constant variable. And what I mean by constant is it's a variable name that has data in it, but since it's constant, you can't actually ever alter or change it. That's just going to show you that being ran real quick. Did I save this? Remember, pop this sucker back up, and we'll say Python test import, and you'll see it says 8. 2 to 3 is 8. And then 3.14, 159, 26, yada yada yada. And that's one example. You can look up libraries, just tons and tons of them. But that's an example of a pre-written library. The great thing about those is there's libraries out there for a lot of common things that you would do. It saves you the headache of having to write the code yourself, and honestly, a lot of it's going to be optimized to the point, optimized for the language to the point that you're probably not going to be able to make code that's as good or as fast without just spending an insane amount of time. And why would you do that when you can just import it? Now the other example I'll show you is I'm actually going to say import functions, and I can't remember if you have to use the extension or not. It's been a while since I've done this. But anyway, functions.py is the name of this other file that we have that has the 2 functions that we had written in it. And then from there, I was going to import functions. So you can think of this basically getting copied and pasted here where import says. And you'll see that I can say hello, Brandon, and print divide, and we'll do 4 and 2 again. And I can't remember if I have to when you import your own stuff, if you have to do the file extension or not. So this may throw an error. We'll have to find out and just see. But I'll run the Python test import. Yeah, that's right. So you don't have to do the extension. I was thinking you didn't, but okay. Oh, also with and same thing with the functions. How I said you want to kind of stylistically keep them at the top and separate. Same thing with your imports. You can do them anywhere, but stylistically, it's a good idea to have them at the top of your code. That way, it's easy to keep track of them. And then also, if you start just slapping them wherever, then it's really easy to start calling stuff from a library or from another file that you've imported before you've actually done the import, which would throw an error because once again it wouldn't have seen the data yet because it hasn't been copied and pasted over. What in the world did I do wrong here? Oh wow, never mind. That's even my mistake. I imported functions. You don't need that. I was trying to pause the video and try to slap that back on, um, so you get forget in a hurry. Just like a second ago when I was importing the math, I was having the math library. I had to say math dot whatever. Same thing with this. Even if it's your own code, you still have to say whatever the name of the import is, which in our case would be functions dot say hello and functions dot divide. That's why it wasn't actually recognizing it and throwing an error because it assumed that I was trying to call a function that was natively in the file that I didn't import. Sorry about the confusion there. But anyways, you can see now that I've correctly did that and said I'm calling this function that's associated with this import by saying functions, which is what I imported, dot say hello, and functions dot divide, then I actually get hello Brandon in 2, which is what we expected, which is kind of neat because that means that like if you have some kind of pre-written code or your own code that you use often, you can just kind of stick it in a file of its own and put the code you want there, and then you can import it and then just call it with the you always have to do any kind of import. You always have to say the name of the import, whatever this is here. You put that there dot whatever function you want to call or constant variable you want to use or etc. And it'll give you the ability to call it. But that's the basics of functions. Um, we'll kind of visit these again a little bit later on in a future video when I talk about lists. Then I'll start showing some more advanced things you can do with functions.